Okay, so calculating the equilibrium concentrations of the reactants or products from known equilibrium constants is useful in many situations. So we have two types of problems. We have, the first is the simplest, where we know what the equilibrium constant is, and we know what all but one of the equilibrium concentrations are. So we write the equilibrium constant expression. We've got all the numbers except one. We put the numbers in, we solve for the missing piece. Or, more commonly, we have the equilibrium constant, and we have initial concentrations, but that's all we know. Ice, baby. Ice tables. So, in this chapter and the next chapter, ice table is probably the answer to most of the things, right? That's the approach. Ice table, ice table, ice table. When in doubt, make an ice table. So diatomic iodine decomposes at high temperature to form iodine atoms. According to the reaction, in an equilibrium mixture, the concentration of I2 is 0.1 molar. What's the equilibrium concentration of I? Well, do we need to do an ice table here? When in doubt, yeah. Well, we don't here. Kc, we have the value for it, and Kc is going to be I squared over I2. I have what Kc is equal to, and I have the equilibrium concentration of I2. So I'm just missing the concentration of I. So we've got 0.011 is equal to I squared over 0.10. So I squared is 0.0011. Concentration of I is the square root of that. Any questions? These are the kinds of equilibrium constant problems we do in Chem 3A. All the numbers except one. Solve for that number. Any questions? 0.033. For the reaction, A goes to 2B, Kc equals 4. A reaction mixture at equilibrium contains A equals 1 molar. What's the concentration of B in the reaction mixture? Well, what's the expression for the equilibrium constant? B squared over A, right? So K is 4, and A is 1. So B must be 2, right? You're pushing stools. Any questions? Okay, so the more common type of calculation with the ice table. So these are your steps, okay? You set up an ice table with the initial concentrations. You represent the changes in concentrations in terms of X, considering the stoichiometry. Then you're going to add the initial and change rows to find the equilibrium concentrations in terms of x. You're going to plug those equilibrium concentrations and the value of k that you were given into the equilibrium expression and solve for x. This is where the solver on your calculator comes in very, very handy. So if you don't have a calculator with a solver yet, I highly encourage you to get one before Wednesday. Well, then it's entirely up to you whether you want to learn how to use that one or not. So that's like a TI-83 or something. So those do all kinds of things, right? They'll tie your shoes for you. But strangely enough, you have to rearrange the equations a little bit to use them. You have to get it to equal 0. And so that's kind of a pain. On the TI-36X Pro, you can type stuff into both sides. You don't have to do any rearranging. It really is a thing of beauty. $25. I know, right? But like I've seen them at Office Max, Office Depot, of course Amazon, right? Has it ever frozen? Of course it has.
She just breaks it.
You had a max iterations error. There was something wrong with your formula. Okay, so let's do this. Here's a simple example. So here we have again our A goes to 2B. Equilibrium constant is 0.33. A is initially 1 molar. So we're going to set up our ice table. Here A is 1 molar, B is 0. Then we're going to mark the change in terms of x. So the coefficient on A is 1. So A is going to change by 1x. It's going to go down because we only have reactant and no product. So this is going to go down by x, 1 minus x. B starts at 0, and it's going to increase by 2x. The coefficient here is 2, so it's going to change by 2x. Then I take my initial value and my change value, and I add them together. So 1 plus negative x is 1 minus x. 0 plus 2x is 2x. Okay? Watch out for those minus signs. They can really mess things up. You just have to, they're squirrely, you got to watch out for them. So we need our equilibrium constant expression. So the equilibrium constant equals the concentration of B squared divided by the concentration of A. So I know what that value is. It's 0.33. And so the concentration of B at equilibrium is 2x. So it's 2x the quantity squared. And A is the quantity 1.0 minus x. Okay, so that's going to be a quadratic equation. Yeah. Gruesome. Exactly. I don't like the quadratic equation either. And I mean, we have cell phone technology, right? It's like, why do we need to bother with that? I mean, I'm glad they taught that to you at some point in your history, but we don't need to do that anymore. Solver on the calculator.
Like number solve?
Number solve. So on the TI-36X Pro, it's blue num solve. It's on the sine inverse sign button. So you hit second num solver. And if you haven't messed it up, it's going to just show you two boxes with an equal sign in between. So on the left of I'm going to just do it just like this. So on the left side of the equal sign, I'm going to put in 0.33, and then I'm going to remove the little blinky thing, the cursor over to the right side, and I'm not going to mess around with simplifying because sometimes I mess up when I do that, and I can just type it in as is. So I'm going to use parentheses, and I'm going to put in 2, and then you might be wondering, well, how do I do an X? There's a button. It says X and Y, Z, A, B, C, D, and T, I think. It's too small, I can't read it. You push that button, it'll give you X. You push it again, it'll give you Y, Z, T, A, B, C, D. Back to X. Just use X. I'm going to close the parentheses and square that. And then I'm going to divide by, open parentheses, 1 minus X, close the parentheses. So one of these days I'll figure out how to do this. What it looks like on my calculator, it looks kind of like that. So I type the equation in, and then I press the enter. And it's going to show me enter and solve, and it's got X equals, and it may have a number in there, or it may say 0. What it does is it solves this equation by iteration. It means it's going to start with X equal to whatever you tell it, and then it will adjust up or down until it comes out and matches on the left and the right. So 0 is often a good place to start. Well, we'll see what happens. We'll see what happens. So then I press enter and it goes to solve X, and I press enter again, and then you might have to wait a few seconds. So it's telling me X equals 0.2489250.549. Now, a quadratic equation can have 2 roots, right? Usually there's one that's negative and one that's positive. So I should look at this value and ask myself, does that work here? Where X is 0.24, or let's call it 0.25, then this concentration would be 2 times that, or 0.5. And this concentration would be 1 minus 0.25, which is still a positive number. If I got X equals 3, even though that's a nice positive number, that can't be a correct root because 1 minus 3 gives me a negative concentration. That's not possible. So you may get an answer that is not correct. So then how do you get it to show you the other root? You give it another starting point. So if it's highlighting or flashing on solve again. So I'll press enter, and now it's got the same value that it gave me before. I'm going to try putting in, I don't know, -3 and have it solve.
Put -3 in the equation.
It says no sign change error. Okay, so that wasn't good. So then I press clear, gives me back to the equation. Let's try -1, see if that's better. And now it gives me -0.33, some other digits. -0.33 isn't going to work here, right? Because it's going to give me a negative concentration for B. So this is the correct solution for X. So my concentration of B is equal to 2 times that. I'm just going to call it 0.25. So 0.50 molar. And the concentration of A is 1 minus 0.25. or 0.75 molar. Yes? Okay, that's a good question. How would a negative ever work? The only time a negative works is if you misjudge the direction. If you have some reactant and product, you've got some of everything, and you didn't look at what Q was and predict the direction, then you may have chosen to put it in the wrong direction, and then you'll get a negative X that will work.
But it's still not correct.
No, it would be correct. Because if you had something over here instead of 0, if this was, if this was 2 plus 2x, and x was a negative number, I'd still have a positive concentration.
That's what I was asking.
So you find the x, you plug it in for your equilibrium values here, and you have to have positive concentrations. Any questions? Isn't this fun? Yeah. You've learned a weird practical application of algebra and quadratic equations. Okay. Consider the reaction N2 plus O2 going to 2. No. The reaction starts with only the product and no reactants. Find the equilibrium concentrations. Oh, God, no. 2 no's, right?
That means we're not going to do this.
So we're going to do this. So N2 plus O2 in equilibrium with NO. So here the equation was up there, and so I'm just going to write it down here so I don't get lost. Make sure you copy the equation correctly. Yeah, you'd be surprised. Okay, so my ice table, initial reaction, initial concentrations says I only have the product, and that's 0.0100. If I only have the product, that means there's no reactant. Okay? So which direction is this going to go? It has to go towards the reactants because there's nothing over there. So this is going to increase. These will increase and that will decrease. So how much is N2 going to increase by? X. And how much is O2 going to increase by? X. And how much is NO going to decrease? Minus 2x. See, that's not so bad. And so now I'm just going to take those two and add them together. So I've got 0.0100 minus 2x. This and that together. Hmm? I did not hear a dog bark. So this is, why did I set it up like that?
Yeah, because if we're losing, then it's the reactant, right? Or no, never mind.
Well, yes.
Okay.
You say, well, how is this the product? If you're starting with only this and you're making that, then yeah, I could write it in the reverse, but then I have to do the inverse of Kc. And, I can solve it that way.
You can keep this part and you end on the top of the equation. You know how
Yeah.
okay, so that's why you did that.
Yeah.
So
So I was given it this way, and I could manipulate it so maybe it makes a little more sense to me, but why? Right? Just do it the way it is.
Chemistry is like a lazy mathematics. Well,
Yeah, use your calculator.
You want to do the least amount of work because there's so much detail that
Yeah.
it's like, why make it harder?
Why make it harder? Why think more than you need to? Save your brain power for things that really need thinking. Okay. So the question is, why is this negative 2 when this is the product? So yes, normally the reactants would decrease and the products would increase. But I'm starting out with no reactants. They can't decrease. Okay? This reaction cannot go to the right because there's nothing here. So it's going to go to the left.
Like, say we have a concentration for N2,
Mm-hmm.
which is 0, then we still have concentration for N2.
Yes. Yeah, you could have a concentration here. Let's make it 10.
Is it still going?
It's still going to go toward the reactants because there's 0 O2. There's nothing here, so none of that can react. Any other questions about what I did, why I did it? No? Okay, so there's my ice table. Now I'm going to write my equilibrium constant expression. NO squared divided by N2 and O2. So I'm told that Kc is 0.055. So that must equal NO is going to be 0.0100 minus 2x, quantity squared, divided by x times x. Okay? I don't know about you, but I don't feel like solving that by hand, right? No. So I'm going to plug this into my calculator. Go right ahead. I bet I can do it faster. How do you know if it's the right number? Well, you plug the value into these expressions that you have, and you have to have positive concentrations. You'll never have two numbers that both give you possible things. So I'm finding that x is 0.00448. So 0.00448, 0.00448, and this is 0.01 minus 2 times 0.00448. So I take the value for x that I got and I plug it into my little equilibrium things here. And I get that N2 is 0.00448, O2 is 0.00448 molar, and that NO is 0.00104 molar. So those are the concentrations of the three things at equilibrium. Okay? Now, if you get an X, and when you stick it in here, you get something impossible, like negative concentrations. That means you're using the wrong root, or you've got something else wrong with the calculation. If the first root that the calculator gives you works and gives you possible concentrations, don't bother looking for the other root. I can't remember a time when both of the roots gave me actual usable things. One of them seems to be always bad. It's giving me negative concentrations, which are impossible. So if you get one that works, just stop. Don't look for the other one. Okay? Here's another one, right? This one only has two things, one reactant and one product. So consider this reaction. Initially, we only have the reactant and no product. Find the equilibrium concentrations. So we're going to make an ice table. ICE. Initial concentration. So the N2O4, 0.0250, and this one is 0. So which direction is this going to go? To the right, yeah. Because there's nothing here, it can't come back. So it has to go to the right. So that means that this one's going to be negative and this one's going to be positive. All right? So which one is going to be X? The reactant with the coefficient of 1. And then this one is going to be 2X. You can do it other ways, but it's so confusing. So just use X for something that has a 1 coefficient. Okay, so then I've got 0.0250 minus X, and this is 2X. I just add the I and the C rows, and I get my equilibrium. So I'm given Kc, and I tell from the equation that Kc is NO2 squared divided by N2O4. So 0.36 is equal to, NO2 is 2X, and that's the quantity squared, divided by 0.0250 minus X. Now I'm just going to go to my trusty calculator. I got 0.36 on one side. It's important that that 2 gets squared also, so inside parentheses 2x squared divided by parentheses 0.025 minus x, close the parentheses. I think it's generally good when you go to the enter and solve, set x to 0 instead of using whatever it throws in there from last time. I'm getting x is 0.0204. So if I put this in here, I have a positive number, and I have a positive number here. So this is 0.0250 minus 0.0204. You can end up with a positive root that doesn't work. But this one works. And then this is going to be 2 times 0.0204, 0.0408.
Can you end up with a negative root that does work?
Yes. You can end up with a negative root that does work. If I predicted the direction wrong, then a negative root is the only thing that's actually going to give me good concentrations. Any other questions?